Today I'm going to look at the Taylor series. The Taylor series and the Maclaurin series are very, very similar. In fact, you can think of the Maclaurin series as being a special case of the Taylor series. The first few terms of the Maclaurin series, fx is f0 plus x f dash naught, etc., will give a good approximation to f of x if we have small values of x. The Taylor series differs in that we will be able to find a good approximation to f of x near any value of x, say x equals a, not just near x equals naught. Well, let us take two functions. F and g. And in this case, let us take g of x equals f of x plus a. The first thing to notice is that g of 0 is equal to f of a. And the second thing I want to look at is that g of x, which is f of x plus a, is a translation of f of x through minus a 0. The gradient of g of x will be the gradient of f of x translated through minus a naught. In other words, g dashed of x is the gradient of f translated through minus a naught. Again, I want to draw attention to what happens when x is 0. G dashed 0 is equal to f dashed a. We can go on in a similar fashion. Similarly, we can take g double dashed x, same sort of argument, is equal to f double dashed x plus a, and this will give us that g double dashed 0 is equal to f double dashed a, and so on. Let's look at the Maclaurin series for g of x. This is g of naught plus x g dashed of naught plus x squared over 2 factorial g double dashed of naught plus x cubed over 3 factorial g triple dashed of naught, etc. Well, g of x at the top of the page is f of x plus a. And g of naught, again near the top of the page, is f of a. G dashed of naught is f dashed of a. G double dashed of naught is f double dashed of a. X cubed over 3 shriek. G triple dashed of naught is f triple dashed of a, etc. And this is the Taylor expansion or Taylor series for f of x about x equals a. Let's look at an example. There is Taylor's series at the top of the page. Find the Taylor series for cot of x plus pi by 4 up to and including the term in x squared. Well, if we're going to use this, we need to think of f of x is cot x, then we're looking for f of x plus pi by 4. F of x is cot x plus pi by 4 is then f of x plus pi by 4. So putting a equal to pi by 4, we get f of x plus pi by 4 is f of pi by 4 plus x f dashed pi by 4 plus x squared over 2 factorial f double dashed pi by 4. So we're starting with f of x equals cot x. Let's just make that x a bit better. I know that I want f of pi by 4. Tan pi by 4 is 1, so cot pi by 4 is 1. I need f dashed. F dashed x is minus cosec squared x. So now we need f dashed of pi by 4. Well, sine pi by 4 is 1 over root 2. Cosec is 1 over sine, so cosec is root 2. Square it, you get 2. So f dashed pi by 4 is minus 2. F double dashed x minus 2 cosec x times minus cosec x cot x. As before, cosec squared is 2, cot is 1, 2 times 2 is 4, and therefore f double dashed pi by 4 is equal to 4. So now we're in a position just to put things together. This will tell us that cot x plus pi by 4, which is f of x plus pi by 4, is f of pi by 4, which is 1, plus x f dashed pi by 4. F dashed pi by 4 is minus 2, plus x squared over 2 factorial times f double dashed pi by 4 is times 4. This is therefore 1 minus 2x plus 2x squared up to x squared. This will give us a good approximation for cot x when the angle is close to pi by 4. In other words, when x is small.